Okay, skill 8. Now, at the end of the last video notes, I mentioned the index. The index matters, right? It was a square root. I don't know, what was it? It was a square root. Here for skill 8, now we're looking at cube roots. So in order to create the parent function table for our square root parent function points, we talked about how we needed to use perfect squares. Why? Well, we needed to take the square root of them to find the output. Same thing here. I don't want to take the cube root of 2 because there isn't a perfect cube root. I want to work with x values, with numbers in my input that could be a cube root. So we're going to go and start at -8 and then go to -1, 0, 1, and 8. Those are the x values for the parent function of a cube root function. How do we find the y's? Take the cube root. So the cube root of -8 is -2. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. Okay, go ahead and graph it with me, please. -1, -1, 0, 0, 1, 1, and then 10, 9, 8, 2. As you connect these points, it's going to curve slightly and then extend out to infinity. Similar to the cubic, but this is the cube root. So it is a little bit different, and we'll talk about that in our next unit. Okay, so what is our HK? Well, this is the parent function, so it's 0, 0. What are the x and y intercepts? 0, 0. Easy, easy. The domain. There aren't any restrictions on x. In other words, I could substitute any number into this cube root and get an output. It may not be pretty, but it will be an answer because you can take the odd index of any number, positive or negative. So we'll say all real numbers or -infinity to +infinity. And as we can see with the graph, the range is going to be the exact same thing. There aren't any restrictions, no asymptotes. Okay, as our graph goes from left to right, yes, our y values are increasing. So we don't have a decreasing interval. We have an increasing interval from negative to positive infinity. Is this function one-to-one? It sure is. What's the rate of change? It varies. And let's go back real quick. My apologies, you guys. Just in case you didn't watch these video notes back to back, reminder that your increasing and decreasing intervals are always written with the domain. Explaining that as your x values go from this value to this value, your y values are either increasing or decreasing. Okay, one-to-one, that means that your function passes the horizontal, let's start with vertical, the vertical and horizontal line test, meaning that the elements within the domain and range do not repeat. They're all unique. Okay, so this is not a symmetrical graph. Oopsie daisies. So we say NA. There isn't a minimum or a maximum because this function goes to negative and positive infinity in both directions. And there aren't any asymptotes. Pretty easy and straightforward function if you ask me. All right, so there is the parent function for our cube root function. Nice. Okay, well, looking at the general form with all the transformations, let's go ahead and write it with the b value also. So a is on the outside. We have the cube root of b. Always factor out the b before identifying the h value, and then plus k on the outside. Okay, looking at our second example, yes, we do have an a value, and it's 2, which means that we have a vertical stretch. If A is greater than 1, it's a vertical stretch. It appears our B value is 1, so there isn't a transformation there. H is -2 because we take the opposite sign, so we go 2 units to the left. And K is 6, meaning that we go 6 units up. Okay, reminder, for our transformation chart, it's the reciprocal of B times X plus or minus H, depending on what H is, and then A times Y plus or minus K, depending on what your K is. So using that idea, the transformation chart for this particular cube root should say X minus 2, since B is 1, there's no transformation there, and H is -2, and then 2y plus 6. As always, I'm going to go ahead and write the parent function points next to the table. I can't see them on my screen. You guys can see them on your paper, however, unless you're writing your notes by hand and you don't have them on your paper. Okay, so we're going to take all of our x values and substitute them in. -8 minus 2 gives us -10. -1 minus 2 gives us -3. 0 minus 2 gives us -2. 1 minus 2 gives us -1. And 8 minus 2 gives us 6. Okay, y values. If we plug -2 in for y, -2 times 2 is -4, plus 6 gives us 2. -1 times 2 is -2, plus 6 gives us 4. If we substitute in 0, we get 6. 1 times 2 plus 6 is 8. And 2 times 2 plus 6 gives us 10. So those are our new transformation points. So graph them with me, please. Remember, our central point, as we can see from our parent function, is at 0, 0. So that means our central point here is going to be at -2, 6. Just keep that in mind for when we start to graph. Okay, I'm going to plot my points. -10, 2. -3, 4, 2, 3, 4. -2, 6. -1, 8. And 6, 1, 2, 3, 4, 5, 6, 10. Okay, that's central point, right? That means that we're going to start from the left, curve up, and then curve out to the right with arrows on both ends of our graph, showing that it goes off into infinity in both directions. Okay, HK, that's our central point. We did identify them at the beginning with the transformations. They are -2, 6. It looks like we're gonna have x-intercepts, but I don't see them in my transformation table. So let's solve for our x-intercepts, or x-intercept, if we just have one. Okay, so in order to do that, we're gonna set 0 equal to 2 times the cube root of x plus 2 plus 6. All right, we're good at this. We've done a lot of solving of radical equations. Hello, skill 6. So let's do it. Okay, I'm going to subtract 6 to both sides. Remember, we have to isolate that radical. And then divide by 2. So we have the cube root of x plus 2 equal to -3. Applying the inverse operation of a cube root, because we have to get rid of that radical, right? We're solving for x. We get x plus 2 is equal to -27. Grand finale, subtract 2, so x is -29. Whew, that's kind of big. All right, writing our coordinate as such, we will have -29, 0. Nice job. Okay, for the y-intercept, we need to plug 0 in for x. So y is equal to 2 times the cube root of 0 plus 2 plus 6. Okay, so that equals 2 times the cube root of 2 plus 6 as we start to simplify down. All right, cube root of 2. Yeah, I'd have to use my calculator. So we're going to leave it just like that, and we're going to write it as 0, comma, 2 times the cube. Well, actually, I'm going to write the radical last. So 6 plus 2 times the cube root of 2. Now, as we saw with the square root, I'm not going to mark you off if you write the radical before the constant. So 2 cube root, of 2 plus 6. It's just more proper notation to write that as the second term. Okay, domain and range. Yep, they are both all real numbers like we saw in the parent function, or negative infinity to positive infinity. And looking at this, since we didn't have any sort of reflections, we still have an increasing interval from negative infinity to positive infinity. Is it 1 to 1? Sure is. Rate of change? Yep, it still varies. No axis of symmetry, no minimum or maximum values, and we don't have any horizontal or vertical asymptotes. So there, ladies and gentlemen, is our second example. And as always, there's a third. So let's go to our third example. Dun, dun, dun. Maybe. Come on, Surface Pro. There we go. And to probably none of your surprises, there is a b value. So we need to factor out the b before we decide or start to do anything. When you factor, you're dividing, okay? So we have -3 times x minus 1/3. Okay, let's identify the transformations. Well, a is 1, so there isn't a transformation there. B is -3, but as I always do, I'm going to write it as -1 times 3 to remind me that we have two separate transformations. The -1 means that we're going to have a horizontal reflection. Okay, the 3, well, in our transformation chart, we're really going to have a -1/3. So that means we have a horizontal compression because we take the reciprocal of the b value. Our h is a +1/3 because we take the opposite sign. So we're going to go 1/3 units to the right. And k is 0, so we don't have a vertical shift up or down. Writing out our transformation chart, we're going to take the reciprocal of b and multiply it by x, and then we're going to add the h since it's positive. Okay, well, a is 1, k is 0, so we just have our y's, and yep, you guessed it, I'm going to write out our parent function points so I have an easy reference. Okay. Here we go with your fractions. Fractions are your friends, ladies and gentlemen. If we take -8 and substitute it in for x, -8 times -1/3 gives us a +1/3. Did I just say 1/3? Yes, I sure did. Okay, start over. -8 times -1/3, good grief, gives us a +8/3 plus 1/3 is 9/3, which is 3. I bet y'all didn't think it was going to work out so nice, huh? Okay, -1 times -1/3 is a +1/3. Plus another 1/3 gives us 2/3. 0 substituted in for x will give us a +1/3. 1 substituted in will give us a -1/3 plus 1/3, which is 0. And last but not least, 8 times -1/3 gives us -8/3 plus 1/3. So we get -7/3. Or if you'd like to write it out so you could graph it a little bit better, it's going to be -2 1/3. Okay, now our y values aren't going to change, so let's go ahead and substitute in -2, -1, 0, 1, and 2. And yes, let me change my color for real. Okay, there we go. And yes, this is our central point. It comes from 0, 0. Okay, graph with me, please, doing your best to get as accurate as you can with those fractions. We have 1, 2, 3, -2, 2/3, -1, 1/3, 0, 0, 1, and then -2 and 1/3, 2. So there we go. All right, doing our best to make this look curved and to include all points with arrows at the end. There is our function. What is HK? Well, it's in our chart and we identified it at the beginning, so it's going to be 1/3, 0. There is an x-intercept and it's in our transformation chart. How excited are we? Again, this is similar to the square root. We see that it is our HK. And remember in those notes I mentioned, HK can be your x or y intercept. Don't discount that it can fit both. Okay, the y-intercept, yeah, it is also in our transformation chart. The domain and ranges are still all real numbers. Nothing has changed as far as restrictions for the graph. Now, we did have a horizontal reflection, so that affected our increasing and decreasing interval. Because we have that horizontal reflection, our y values are now decreasing from left to right. So we don't have an increasing interval. We decrease from -infinity to +infinity using the domain. It is 1 to 1 still. The rate of change still varies. We do not have a symmetrical graph here. We do not have a minimum or maximum value because the graph goes off to infinity and -infinity for our range values. And we don't have asymptotes because we don't have any restrictions. Hey, ladies and gentlemen, that is example 3.